Far this year, when we've been learning to graph, we've used a table of values that we then converted to the graph. The goal today is to use what we already know, but to find a nice solid shortcut using something that we call slope-intercept form. Before we start that, though, we're going to review what we have been doing so far. So if I was given the equation y equals 2x plus 3, what I'm going to do is create a table of values. And if you remember, you can create any table of values, but my personal favorite has the x values -2, -1, 0, 1, and 2. These are the smallest possible x values, but you could use any 5 that you wanted. So in the case of if I plugged in -2, I would do 2 times -2, which is -4. -4 plus 3 would be -1. If I plugged in -1, that'd be 2 times -1. That's -2 plus 3 is +1. Plugged in 0, that'd be 2 times 0, which would be 0 plus 3 will be 3. And at this point, we would see the pattern, and we would do 5 and 7. Now we would move to the graph, and we plug in each of these ordered pairs. So I would go -2, -1 would be right there. -1, +1 would be right there. 0, 3 would be here. 1, 5 will be here. And 2, 7 will be there. And then we draw a line through our values. It goes both directions. And we put an arrow. And that's what we've covered so far. It's not an incorrect process, but it is a little slow. So the goal of slope-intercept form is to do the exact same process that we just did, but much faster. So what we're going to do is we're going to take this same line, and we're going to graph it using slope-intercept form. And this is the most important thing that you have to write down about slope-intercept form. Slope-intercept form is always written in the form y equals mx plus b. And if you think of it as the YMCA song, you'll see me doing that all the time. Just ask, and we'll show it in class. If you do the YMCA song to the tune of y equals mx plus b, I will give you SPs for that, so make sure you bring that up to me. But in the form y equals mx plus b, the y and the x are the two variables that we've been working with, and m and b are just numbers. M stands for the slope or rate of change. Once again, when we talk about slope, we're always thinking rise over run, same as we've always been doing. And B, we always use that as the beginning value. Well, the beginning value is the y-intercept. And the y-intercept is along the y-axis, so it's going to be x comma something 0 comma something every single time. So what we usually do is we put a number here for b, and then we plug it into an ordered pair. Now let's look at our equation that we had. Y equals 2x plus 3. And if we had this in the form y equals mx plus b, our m is 2. But we also can write that as 2 over 1. And we do that because when you're thinking of slope, you're thinking rise over run. So rise 2, run 1 every time. The b value here is going to be a +3, but once again at the bottom, since it's along the y-axis, or our beginning value, we would write this as the ordered pair 0, 3. And actually, that's all you need to graph this line. First of all, we start with the beginning value, our y-intercept, and we go up 0, 3, and we graph right there. The next thing that we do is we take our slope, which is +2 over 1. So we're going to rise 2, up 2, and then we're going to run 1. Goes right there. And we can do that infinitely. We can rise 2 again, and we can run 1 over here. Now, what's also really sneaky about this is if you use the slope intelligently, you can actually go down and left to follow the same pattern. And I'm hoping at this point you realize that what we made is the exact same line that we'd made in the other slide. And that's because when you're graphing with slope-intercept form, you're not graphing different lines. You're actually graphing the exact same thing, just faster. So let's do another one. This is where slope-intercept form becomes more effective. As soon as we see a fraction in here, doing the table method would be even more difficult, and it would be less exact. But if we do y equals mx plus b, we know that the m, or the slope, is 2 over 3, and it's already in a fraction. And the b value is negative 3 this time. So we go 0, comma, negative 3. And that's all we need to graph. So we go to the b value first, which is 0, comma, negative 3, right down there. Now we're going to use the slope, which is rise over run again. So we're going to rise 2, 1, 2, from the point. This is a mistake people make. Frequently, they'll rise from the origin. No, you rise from your b value. So we rise 2, and we're going to run 3. 1, 2, 3. And there's our first point. Now, if we wanted to rise 2 and run 3, 1, 2, 3, again, we can go over here. Once again, we can do the exact opposite. We could do negative 2 over negative 3. So we could rise negative 2 and run negative 3. 1, 2, 3. And we will see that we're on the same pattern. If you do everything correct, obviously you're going to make a line. If you make a mistake, obviously the line would disappear. So we have our line. Now, one of the things that I will sometimes ask you to do is after you made your line, I would ask you to make a table of values. Well, you can actually do it in reverse. I notice that I have negative 3, negative 5 is on my table. I have 0, negative 3 on my table. 3, negative 1, and 6, positive 1. And now I have a table of values from slope-intercept form, and it went so much faster than if I had to make the entire table. Let's do one more. If we're in our form y equals mx plus b, like we've been doing before, that means our m value is right here, or negative 1/4. Our b value is right here, so negative 2 or 0, comma, negative 2. And now we have everything we need to graph. I graph the b value first, the beginning value, at 0, negative 2, right down there. And now I graph our slope, which is rise over run. So I'm going to rise negative 1 and run 4. 1, 2, 3, 4. Now if I rise 1, I go down 4, I ended up off the chart. So I'm going to go back and left. And there we have our 3 points. Now, just like always, we graph our line. And we make our arrows. And now I can make a table as well. So from our table, we have negative 4, comma, negative 1. We have 0, comma, negative 2. And we have 4, comma, negative 3. And that is using slope-intercept form to graph. There is a video retake here. If you have questions, please, please, please let me know.